Welcome back. In this video I'm going to show the finishing of the ST1100 dashboard panel that my brother-in-law sent me. You can take a look at my prior videos to see the initial construction of this model, but today we're going to take a look at finishing it out, doing all the trim work, and then of course copying this complex curved shape that emerges from the face of this thing that ultimately has to fit inside a cutout on his dashboard. So that's a pretty important shape to model, and in a moment here I will show you how that's done using a scanned image of the original gauge panel. At the beginning here you can see I'm just pulling these faces down a little bit. In hindsight I should have used the extrude function and not the push-pull function, because the push-pull led to some complicated geometry that I had to repair there. But ultimately it's really not going to matter all that much because I'm going to be cutting this model at the bottom of the lower tab there, because I don't want the block to be too tall. So I've created a sketch on the side of the model, and then I use that sketch as a cutting line to cut the bottom half of the model off. And you can see there now the tabs come all the way down to the bottom with some interesting geometry there that I'm going to repair here in just a moment. But this will allow me to print the model without having to rely on too much support under those tabs. I really want those tabs to be nice and strong, and so having supported faces is not desirable in this case. So I'm just tapering and extruding these down so that it has a little bit of a chamfer to it. That way when it prints, it should print really nicely. And I'll just need to use a tiny bit of support under the bolt holes there. Here I'm creating a sketch on top of the tabs. If you noticed earlier when we were looking underneath the model, those bolt holes had an interesting chamfer underneath them because of using the push-pull function. So here I've created a circle on top that is enough clearance for the head of the bolt and the washer underneath, and I'm going to create an offset cut that will provide a nice flat surface for that fastener to sit on. And there we have it. I'm going to repeat the same thing on the other side, finishing up with a small fillet on those sharp points just to allow it to print nicely without any fragile spots. Now the fun part. I'm going to import a canvas here, and this is a scan that I had previously done just on my flatbed scanner. I placed the gauge on there and took a nice scan of it, and then I'm going to scale this until the edges of the square face just line up with the edges of the box that we had modeled before. The key here is only worry about the faces that are closest to the glass. You can see there that the triangular tabs do not line up, but that's okay because those weren't actually on the glass when I scanned this, so they're not going to be in scale. So what I've done is I've scaled the model to the size of the square box, and now I'm using the spline tool and laying out the points that will mark the apexes of the curves and the flattest of the flat spots within that complex shape, and then I just go around adjusting the handles of each of those curves until it fits the shape of that embossed raised surface there. Getting the hang of spline tools, or maybe the pen tool if you've ever used something like Photoshop or the GIMP, can be a bit challenging and frustrating at first until you get the hang of it, but once you understand how splines work, they're a really powerful tool that you can use for creating complex vector curves in any kind of modeling environment. So I'm just going to continue working my way around the model here, looking at the image and adjusting the splines until it fits just right. And you'll see here in a moment I'll zoom in on a couple spots and make some fine-tuning adjustments there. It's also helpful in Fusion to adjust your zoom level, because the snap level, notice how it snaps between grid points there, the snap level changes depending on your zoom level. So if you need more detail and the snapping is frustrating you, just zoom in a little closer and those snap points will get finer in their detail range. You can see I'm doing that here to get this top curve to align properly. We just continue fine-tuning the edges here pretty meticulously. I'm looking for the point where the shadow meets the face and continue adjusting that. And once I'm satisfied, then I just extrude this section up, adding a small amount of draft angle to it as well, just to match the original model and to give a little bit of wiggle room just in case it doesn't quite perfectly fit the hole. That draft angle should help a little bit. Now I'm creating a sketch on the top plane of the square body here, and creating midpoint lines across that rectangle to define the true center of that rectangle. Change those into construction lines so they're not used in the modeling itself. And then pulling up my screenshots of the new volt gauge that my brother-in-law is using to enter in a couple circles, which we will then extrude into the cutout for this gauge. I cross-checked it against a different diagram, found out that the inner hole was a little bit larger than I had originally thought, so I go back into the sketch and make adjustments to that inner hole's diameter, and adding a 0.5 millimeter extra just for clearance. Then we come back and I select my sketch objects, extrude them through to cut out the holes, repeat it again with the larger object to create the counterbore. Once I've selected the profiles, I use Fusion's offset function to start the extrusion from that very top plane of the curved projection and bring it down to the final counterbore depth, which you can see there. And then we're just about done with this model, so I'm going to save it, and then I'm going to go through and add the fillet radius to all of the exposed edges. Finally, adding some small fillets to the top edges and a small chamfer to the bottom of the hole, just so that the first layer printing doesn't interfere with the hole's diameter there. And then lastly, we're just going to save this as an STL so I can print it. I'm going to choose high resolution. I prefer to save my STLs in ASCII format. I just feel like they work better on the Mac, but your methods might vary. So here I'm just doing some quick sanity testing against the model by using a projected image of the object against my screen with it life size, just to make sure everything looks good. Finally, in Simplify 3D, I made a test print first just to make sure I had everything right. This way I didn't have to waste a lot of time printing the whole object. I just printed the top few layers and held it up to the original model to make sure everything looked right. I didn't show the printing process of this component just because it's really not necessary, but eventually I came back and printed the whole object from top to bottom, and you can see there I'm just checking everything to make sure it fits and make sure it's lined up the way I want it. And finally we will print this thing. There we have it. We took essentially a mirror image of this piece, but added the hole so my brother-in-law can install a voltmeter in this part. So you can see here, surface finish is acceptable. I've got a little drag mark from the nozzle here, but not too big of a deal. Back is good. The supports came off of the relief for the screw heads there pretty nicely. And if we compare them side to side, you can see we've got all those compound angles accurately captured. Accurate enough for a flexible plastic part that sits on a motorcycle at least. So I'm excited to send this back to him and see it installed with the final product. So as always, thanks for watching. If you like this content, please like and subscribe.